This is 2017 number 3. We've done a couple of these area problems under the graph before, but I'm going to do it again, and I'm going to make a t-chart as I do this, because on this problem down here I'm supposed to find the absolute min, and justifying my answer will be my t-chart. And I'm going to use this information that f of negative 2 is 7, so we're at negative 2 here for f prime. So when I do my t-chart, I've got x here, I've got f here, and I already know that negative 2 gives me out 7. So I'm going to be going backwards to get the area of this triangle right here. So because I'm going backwards, and negative 2 is really where I'm starting, when I do this, this is actually going to be a negative of the integral of negative 6 to negative 2. So 4 times 2 is 8. Half of that is 4. So at negative 6, we're going to get 3 out of that, because I actually have to subtract it because I'm going backwards. And again, because of finding the absolute minimum, I am going to be using the endpoints and the zeros, because the critical numbers and the endpoints are the numbers that are the possible max and min values, the absolute max and min. So the next 0 is a 2. And the far right side is a 5. So I need to get the area of that semicircle, and that circle is pi r squared. That's half a circle, so I divide that by 2, and the radius there is 2, so I get 4 pi over 2, which ends up being the area is 2 pi. So since it's down below, it's negative 2 pi, because it's under the x-axis. And I'm going now to the right of 2, so instead of having negative 6 up there, I have a positive 2 here, so that's in the right order, so I keep the values the same. So this will be 7 minus 2 pi. And then I got this triangle over here to the right, which is 3 times 2 is 6, so this area is 3, so I got to add 3 more because I'm still going to the right. So that is 10 minus 2 pi. Now again, I did that chart because of part C. So I've got my 2 answers here from my chart. F of negative 6 is 3, and f of 5 is 10 minus 2 pi. And I'm going to go ahead down here and solve the absolute minimum. So I want to find the minimum value of this, which would be right here, because pi is 3.14, so 7 minus 6.28 is the smallest value. So we would say f as absolute min equal to 7 minus 2 pi at x equals 2, because, and that chart up here is my reason for that. So that's the end of A and C. So I'm going to go on and do part B. B says, on what intervals is f increasing? So f increasing means we're looking, where is f prime greater than or equal to 0? So if I look here on my graph, which is f prime, that part and that part, f prime is greater than or equal to 0. So we would say f is increasing on negative 6 to negative 2 and 2 to 5, because f prime is greater than or equal to 0 on those intervals. Now you could put brackets at the 2 and at the 5, because it increases all the way to that 0, but I've been told they will not count parentheses wrong. And part D is the last one. For each f double prime of negative 5 and f prime of negative 3, find the value, explain why it does not exist. So since this is f prime, f double prime is the derivative of that, which means the slope. So I need to get the slope of this segment up here at the top. So I need to get that slope right there to get f of negative 5, because negative 5 is right here. So I'm going to go down 2, right 4. So f double prime is down 2, right 4, which is negative 2/4 is fine. You can reduce it to negative half. You could even plug in the negative 6/2 and the negative 2/0 in the slope formula and show where that comes from. Now f double prime of 3 is right here. Well, we have a problem there because that's a sharp turn, but we're not allowed to say a sharp turn anymore. So we can say f double prime of 3 does not exist. And the reason it does not exist is because the limit as x approaches 3 from the left, and we want to show the limit of the slope there. So when we show the limit of that slope, we would say f prime of x minus f prime of 3. And on the bottom, we would have x minus 3. And then we would want to say does not equal. And then we're going to do the same thing for the right side of that. The limit as x approaches 3 from the positive side of the exact same function, or the exact same slope. And I hope you can see that if you look at the slope on the left side approaching 3, that's a positive slope. On the right side, it's a negative slope. So that's the end of number 3.